Okay, let's do lesson 9.2, factoring using the distributive property, page 481 in your book. First of all, what is factoring? Well, to know factoring, you have to understand what factors are. When you take two numbers and multiply them times each other, that's factors. 2a times this number 6a plus 6, or plus 8, these two numbers, 2a and the polynomial or binomial inside the parentheses, are the two numbers, are the two factors in this multiplication problem. Okay? And when you multiply it out, you remember how we did that. We multiply 2a times each of the parts inside the parentheses. We get 12a squared plus 16a. And then factoring is the act of taking it from that answer back to the original factors that made up the multiplication problem. So in this example here, when we move it from 12a squared plus 16a, we look at it and we can say we can pull a 2a out of there. We can pull a 2 and an a out of both of those. And when we pull the 2 and the a out, we get 6a, because 12 divided by 2 is 6, and a squared divided by a is just a, and then 16, pulling a 2a out of that, you get 8. And that's called the factored form. We've taken it from the two numbers that we multiplied, two factors, got a product. We've taken the product and gone back to our factors. And that's the factored form. But when you're asked to do that, there's a concept of it has to be completely factored. And what does completely factored mean? It means that the answer that you have can't be factored any further. And if you look at our answer right here, I can pull a 2 still out of the 6a and the 4 and the 8. So I did that again. I put 2a, put open parentheses for the whole 6a plus 8, and I changed that by factoring a 2 out of it. 6a divided by 2 is 3a, 8 divided by 2 is 4, so I end up with that. And then if I remember that I can multiply in any order, I can take 2a times 2 times 3a plus 4, and then I simplify the 2a, those simple monomials can be multiplied together, and I get 4a times 3a plus 4, and now I've completely factored the original product, 12a squared plus 16a. Let's look at an example of factoring. Example 1a from your book. Okay, 1a. Here we go. All right. It is 12a squared plus 16a. Now, I'm going to do the same problem we just looked at, but I'm going to show you the correct way of figuring that out. Okay? What you want to do is you want to factor each of your numbers, and that'll be 2 times 6 is 12, and then 2 times 3. So I know that 2 times 2 times 3 is 12. So 2 times 2 times 3 is 12. And then a squared is a times a. And now I've factored completely 12a squared. Now let's do the other monomial in my term, in my binomial. 16, I'll go 2 and 8. 2 and 4, and then 2 and 2. So I know that this number is 2 times 2 times 2 times 2 times the variable a. Now, in order to factor out a number, what you have to do is look for, after you get factor forms of each of your monomials, look for common terms. And here we have a 2 and a 2 that are common. And then we have another 2 and another 2 that are common. Then there's no 3 over here, so the 3 is not in both. And there's 1a here and 1a here. So we now know that this problem is factor is 2 times 2 times a. And if you explode that out, that is 4a. And what's left over? Well, in my first term is just 3a. You can see right here, there's the leftover terms. Okay? I'm just kind of highlighting them a little bit. So we got 3a. And over here, what's left is these two 2's. So 2 times 2 is 4. And remember, there was a plus sign between the two, so we put the plus sign in. And there is our final factored form for that polynomial. And if you notice up above, it's the same answer we got up above. Same problem, same answer. I just showed you the best way of doing it. Okay. All right, let's take a look at the second example in the book. Our first example, the second part of it, 18cd squared plus 12c squared d plus 9cd. Now in this example, we're going to do the same thing. We're going to break these numbers down, 2 and 9, 3 and 3. So we know that this monomial breaks down to 2 times 3 times 3 times c times d times d. All right, now let's break this guy down. 2 and 6, 2 and 3. So this guy is 2 times 3 times c times d. And then let's break down the last one, 3 and 3. So he is 3 times c times d. Now we look for common terms across all of them. Let's see, we have a 2 here, a 2 there, but no 2 there, so that 2's out. We got a 3 and a 3 and a 3, so let's underline that. There's a 3, a 3, and a 3. There's not a second 3 here, so that 3 can't go. How about this c? C, 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 all right, and D, D, D. All right, well, there's no more second D here, or here, so we've now found all the common. So our common factor is 3 times C times D, or 3CD. Okay? And then what's left over is, in this first term, 2 times 3 is 6, and D. And then we have a plus sign between them, so we put the plus sign. What's left over? 2 times 2 is 4, and a C, so 4C. And another plus sign between the two. So now we have what's left over here is just a 3. And we have now factored this polynomial, and it is in its completely factored form now. And let's just check that in our head. 3 times 6 is 18, c d squared. Is that our first term? 18 c d squared. Yep. 3 times 4 is 12, c times c is c squared, d times nothing over here, 1 is d, so we got 12 c squared d. 12 c squared d. And finally, 3 times cd, 3cd times 3 is 9cd, and that's our last term. So we've just checked our answer, and this is good. All right, now let's talk about the concept of factoring by grouping. So what do we mean by that? Well, sometimes you've got a monomial, or a polynomial, that can be grouped in a certain way to allow you to do factoring. And let's take a look at that and see what I mean. We've got 4ab plus 8b plus 3a plus 6. All right. Well, the first thing I notice about these is that the 4 and the 8 are divisible, can be factored, and A, B, and A, they've got some common letters, so I'm going to group those two together. And 3 and 6 can be factored, so let's group those together. All right. Now, once we've done that, let's take a look. If we factor these out in our head, 4 can go into both 8 and there, so let's pull a 4 out. And we got a b in both terms, so we can pull a b out. What is left? 4b taken away from 4ab leaves me with a. Plus, well, take 4b into 8b, I get a 2. Okay, now I still have my plus sign. Now I'm going to factor 3 out of this guy. 3 times, or 3a divided by 3 is just a. 6 divided by 3 is 2. And you'll now notice that I have the same term being multiplied by these two different groups. When you have that, you can rewrite this as 4b plus 3, the two outside terms, times a plus 2. And I've factored that process right there. Okay? And that's using grouping to factor. You notice this is just the reverse of the distributive property. I'm going backwards on the distributive property. Instead of going from here and distributing it out, I notice that I have the end results of the distributive property and I back it into this factors. Okay, so that would be my answer right there. All right, there's another function of grouping that is a little bit hard to notice, and it's called, line here, additive inverse. This is a special case when you have two binomials and notice the two different binomials here have the same letterings. They're just opposite of each other. 7 minus y and y minus 7. What happens is I realize that if I take 7 minus y and multiply it, let's take 7 minus y and multiply it times negative 1, what do I get? Well, I get 7 times negative 1 is negative 7. Negative y times negative 1 is positive y. And I can rewrite that as y minus 7. So now if you look at that, this is called an additive inverse. If I can take one of the terms, multiply it times negative 1, and come up with the other term, which I did in this case, 7 minus y times negative 1 ends up being y minus 7, and it's the same term as the other term in my pair, it's called the additive inverse. And when you have that, you have a special case of being able to do factoring by grouping. Okay? You can get the y minus 7 in both these spots by doing the multiplication by negative 1. Let's see that in action. Okay? All right, let's see that in action. Let's say we actually have this problem. 35x minus 5xy. And then we want to add to that 3y minus 21. Okay. Now, first thing I do is I look at my grouping concept, and I'm going to group it. I'm going to say I can get a 5 out of both of those and an x out of both of those. So let's group that as 35x minus 5xy. And I can get a 3 out of both of those. So let's add 3y minus 21. And all I did is group them so far. Now I'm going to actually pull the factors out. All right? So if I want to divide 5 and 35, I'm going to divide them both by 5. So I'm going to pull a 7 out here. 7 into 35. Oh, and I'm also going to pull an x out because there's x in both terms in here. All right. So now what do I have left? When I divide 35 by 7x, I have 5 left. Okay? Sorry, when I divide all right, I have to pull that out. I did that wrong. 35x. Start over right here. Starting over. Okay, let's see that in action here. Suppose I have the actual term 35x minus 5xy plus 3y minus 21. Well, I'm going to see that I'm going to do some grouping here. I've got an x, and 35 and 5 are divisible by 5. 3 and 21 are both divisible by 3. So I'm going to group these two and these two, and that's what I did here in this step right here. I just put parentheses, same problem, I just put parentheses around them. Okay. Then what do? I say, well, hey, now I can pull something out of this. On this one, I can pull a, let's say, 5x out of both of them. If I pull a 5x out of this guy, and, oops, I wrote it wrong. Let's not do that. Let's do this. If I pull a 5x out of this guy, all right, now 5 into 35 is 7, x and x is 1, minus, I pull a 5x out of this guy, I just got a y left over, 7 minus y. Now on this guy, on this side, I'm going to pull a 3 out. So I pull a 3 out, I get y out of the first term, minus 7. And that's when I realized that I've got that special case, the additive inverse, 7 minus y and y minus 7. Remember from up here? It's the same problem from up here. We know that we can multiply times -1 and get the special case of factoring, okay, for factor break grouping. So we're going to go ahead and do that, and we're going to do it on this side. So we'll say 5x times -1 times 7 minus y plus 3y minus 7. And when we say that, we multiply times -1, all we have to do is extend the -1 into our term in front of the 7 and change this to y minus 7. Oh, I did that wrong again.